So we use the knowledge and transformations to compare the graph of log base c of x to log base c of all this information. So just like an exponential, your base needs to be the same, right? In exponential, we had to have the same base. That didn't change anything, but we had to have those and everything else changed around it. Same thing here. Logs have to have the same deal. So we're going to look down here. We don't need to draw any of that. We're just going to go here. We're going to write the transformations associated with this. So what does this 2 in front do? Vertical stretch by a factor of 2 about the x-axis. And what are we comparing all these equations to? What's the original equation? Y equals log, in this case, what are they all? What base? 3. That's why we're saying we're comparing them all to this graph up here, the log base 3 graph. So we're going to vertically stretch it. So we're going to take all of our x's and keep them and multiply all of our y's by 2. So it's going to bring it up here and down here. But is it going to change my asymptote? My asymptote's at 0. Is x equals 0? Has it changed it? Stretching it? No. Okay. This one I have a horizontal translation 2 to the right. What is that going to change? They all change the graph, yes. But how is it going to change the graph? The asymptote's going to move from 0 to positive 2. Yes, so the asymptote's going to move from 0 to positive 2, but it's still going to be greater than it. We agree? Okay, what happens here? Is this with the x? No. If you put brackets around it, is it with the x? No, you put the brackets around it. Yeah. So it has to be typed with brackets in order for it to be a horizontal translation. If you put brackets on it, no. So, man, it's going to be the minus 2 is at the back by itself. So what is it? Okay, is that going to change my asymptote? No, it's a vertical line, right? If I move the vertical line down, it's actually just keeps going. It can't, yeah, it's cool. So, do any of these transformations change the original domain or range? So the range of all of these is what? It's doing the range. YER. The range of it is YER. We agree? Goes on for life. It's like a disco but weird one. I got like just it's like this arm sore. It doesn't want to come out. It's not coming out to play. Yeah, it's a bad disco. Okay, so it's going on forever up and down. So it's YER. So no matter what I do to it, unless it's a word problem which restricts like what values of y I can have, it's YER. The range is not changing. The only thing that's going to change on these possibly is the domain, correct? And what's the only thing that can change the domain? 2 things. I can horizontally translate and move my asymptote. Or instead of it being greater, it could be reflected in the y. Are any of these reflected in the y? No, because they have to be with the x. So the only one that actually changed is this one. Instead of it being x is greater than 0, it's going to be x such that x is greater than 2. Why isn't it equal to? Because it has a dashed line through 2, right? That line doesn't actually exist. It's an asymptote. It curves there. It's not actually going through it. So what's the asymptote for the first one? X equals what? 0. What's my asymptote for this one? X equals, yeah, 2. And what's the asymptote for this one? X equals 0. It didn't move at all, right? It needs to move to the right or the left. They're all 3 separate equations. They're not building off of each other. Okay? So what's the only thing that moves your horizontal asymptote? Or sorry, vertical. Horizontal and exponential. Yes. So the vertical asymptote is equal to the horizontal translation. And your domain is x such that x is greater than the horizontal translation, XER, or the domain is going to be x such that x is less than the horizontal translation, XER. When? The first one is if there's no what? When is it just greater than? If it's just a horizontal translation but no reflection in the y-axis. The x is less than h of t is when there's a reflection in the y-axis because it causes your graph to be going like this to now be going like this. So it's less than that, right? So this is when you have a reflection. And exponential is the complete opposite, right? A vertical translation moves your horizontal asymptote. And what causes it to be less than? A reflection in the x-axis, because it's normally up here, it's now down here, right? Reflecting about the x-axis. You agree? And what are exponential and logarithms? They're what of each other? Inverses of each other, yes. Okay, we're going to go to example 2. What's the catch on example 2? Oh, this is going to burn you guys all on the diploma. You have to factor the bad boy out. If the horizontal stretch is not taken out, then your horizontal translation is wrong, right? Because the horizontal translation only works if you have a 1 in front of the x plus something or a 1 in front of the x minus something. Right now, I don't have a 1 in front. I have a 2. So I have to remember to take it out of there. It doesn't matter what unit we're in. We need to remember to take that out or we're going to be in trouble because they will put a question like that. I'd be very shocked if they don't. Okay? So, and if they don't, I will. So there we go. Someone will. So we're going to have y equals negative log 2 bracket x plus 3. And if we take out a fraction, say the horizontal stretch was a fraction, when we divide by a fraction, what do we actually do? Multiply by its reciprocal. So if we took a half out, we'd actually be multiplying by 2. Okay. What's the equation of the asymptote? X equals negative 3. This is true. What's my range for every log unless it's a word problem? Y-ER. Did it first because it's the easier one. Or negative infinity to positive infinity. We agree? The domain is going to be x such that x is greater or less? Greater, because the reflection here is not in the y, it's in the x. So your graph, instead of it going like this per se, it's now going like this. Really can't watch this on the podcast, but okay. So if it's going like this, it's now going like that. Did that change greater at all? No, it's still on the right-hand side of the asymptote. And your asymptote's actually a negative 3, not there, but whatever. So it's going to be greater than negative 3 XER. Now some people will say, I'll just punch in my calculator, Lepp, and then it will tell me the ways. Then I say, I give you an equation with all variables, no numbers. And you're like, oh, dang it. Right? So we need to know our rules because your answer might be x is less than negative a or something like that. Right? Because there's a negative in front of the x, I know it's less than. And because it's moved a to the left, it's x equals negative a kind of thing. Okay? So we need to know our stuff backwards and forwards, not just bank on our calculators. Okay? The x and y intercepts, if they exist, x-intercept means y equals 0. So I'm going to have 0 equals negative log 2x plus 6. Bless you. Bless you. So I have the negative in front of here. And the catch here is I don't know the x beside the log. If I don't know the x beside the log, what do I do for now? Convert it to exponential. But the only way I can convert to exponential is if there's a positive 1 in front of the log, which there isn't. So what could I do? divide by negative 1. So I'm going to get 0 equals log 2 to the 2x plus 6. And now I can actually change it to exponential. We agree? So it's going to be 2, the base of the log, which is the base of my exponent, to the 0 equals 2x plus 6. What is 2 to the 0? 1 equals 2x plus 6 minus 6. No, it doesn't. No. Negative 5 equals 2x. Stop. Divide by 2. X equals negative 5 halves. Yes. So my x-intercept for this one is at negative 5 halves and 0. My y-intercept, I'm going to plug 0 in for x. This one's easier, right? So you're going to have y equals negative log 2 times 0 plus 6. Y equals negative log 2 and 6. So y equals negative whatever that is. It's going to be 2 to the 2 point something. Because you say 2 to what exponent is 6? That falls between 4 and 9. 2 to the 2 would be 4, 2 to the 3 would be 9. Or 8, sorry. So it would be 6. It could be 2 point something. 2.58. My reasoning skills? Yeah, it's 2.58. No. I have no idea what you did, but it's all right. And that also doesn't reason itself correctly. Because you rounded it. 2.58 is rounded. Okay. It is. Okay. The x-intercept. What is when you hear x-intercept? What should you think? So the x-intercept of the graph of function f of x equals log ax minus d. You're going to get 0 equals log ax minus d. So if you don't know the x value, and the x value is beside the log or in the base, what are we going to do? Change it to exponential. So we're going to get a to the 0 equals x minus d. And some people freak out. They'll add the d over, and they're like, a to the 0 plus d equals x. And they're like, it's not there. But I did it right. So a to the 0 is 1, so it's 1 plus d. So it's going to be c. What do you have to remember with e? Or with 8. Why did I say e? Don't even know where that came from. 8 starts with an e. You're welcome. Okay. Back to the 2. So we're going to get y equals log 2 x plus 5 over 2. So it has a horizontal stretch by what?
1/2.
Yes, 1/2. So p equals a half. And a horizontal translation, how much left? Which is, when we add those, 6 halves, which is?
3.
The delay was on the just 6 divided by 2 part. Everyone else was golden with the half, 5 halves. Okay. Number 9, an equation of the asymptote. What affects the asymptote in this entire equation for a log? Which means it's 2 to the, so what's it going to be? X or Y? X, because it's with the X. Yay. Okay? We're just, I feel so like you're there. Totally.